Welcome to this video. This is the sixth video of the series. I think in this video, I'm actually explaining some performance measurement metrics for tracking applications such as aeroplane tracking or similar. So, yeah, I think we defined the application scenario and then performance measurement categories like just solely based on the sensor measurements of the targets, not that actual path, actual tracking path estimation. And also it can be tracking calculation based or tracking finding based tracker dependent metrics that can be algorithm free and algorithm dependent. Algorithm free can be generalized, can be applied to anything. Algorithm dependent, those are mostly to identify how a particular algorithm, I think the aspect the algorithm is trying to measure, how it is doing for that the performance measurement. So algorithm free, tracker dependent, it can be cardinality based, like a count of valid tracks, time based, like rate or latency, or depending on available truth to track association, or unavailability. Unavailable truths like consistency of estimation when the truths are not there, how the tracking algorithm is assigning. I think consistent in terms of estimating the tracks. So yeah, cardinality measure, we describe time measures. Let's see. Okay, in this video, you will be doing the accuracy measurement based performance measures for tracker dependent applications, for tracking applications, right? So I really should be saying in the beginning anyway. So root mean square error. I think at this point, I think I can share my screen because of the equations. It will be easier to do it. So root mean square error. So this is the error. Let's see. Tracker in relation to truth or in relation to sensor measure. I will say in relation to truths. So yeah, the Euclidean error, and you are doing the summation over many Monte Carlo runs and for each scans, and then averaging and then taking the square root. That is the root mean square error. So square is here, averaging here, and root is there. So this is the error. So just the terminology, what does this means? The kth scan health target in Monte Carlo run. I think we are doing it for all the targets, for all time stamps, and all the Monte Carlo runs. We are averaging. I think for one particular time, in this one particular scan, we are finding the square error, and we are doing it for each target. Then we are averaging over the entire Monte Carlo runs. That is the root mean square error. What is the average Euclidean error? Okay, average Euclidean error, this square will not be there. It will be just the difference of the estimated with the truth. Or if you want to do in relation to sensors, anyway, so this will not be there. And average, it will also will not be the root mean, the square root will not be there. So let's see, so this is the equation. So the square is not there, it's just the difference. However, we're taking the absolute value. So the direction doesn't, everything remains the same, but the square root is not there. Anyway, I think there are will be some differences. I think the larger errors, whether they're amplified or not, or smaller errors, they're amplified or not. So those kind of things, there will be some differences. So what do you want to do? So geometric, what do we mean in terms of geometric mean? I think multiply and nth root, right? To the power 1 by n. That's the geometric thing, right? So in this case, I think it is just, you can, I think geometric, if we just multiply, smaller can be smaller, get too smaller to understand. And I think for greater than, if it's not fractional, geometry can just amplify things too much. So what do? We took log, so that we just do the sum. Yeah, I think average Euclidean error, you can just say this term will be based on log. Yeah. And harmonic, it is also based on average Euclidean error. Average Euclidean error, yeah, I think harmonic, you means you have to put everything reciprocal, right? 1 over everything. And again, this term, you have to also put reciprocal here, 1 over error. I think you can see it for each scan time, for each target, you take the estimated error, and then you put 1 divided by estimated error, and then you find it the average, and 1 divided by entire average, that is the harmonic. Okay, 1 over sum of, okay, anyway, you know it, right? So it is coming from average Euclidean error. Okay. So now come back to sensor based. I think one of the category of sensor measurement related performance metrics. In that case, we find that probability of detection. It's just that detection. There is no track here, right? Probability of detection that we find out, and the detection gap, average, minimum, maximum, coverage, average, minimum, maximum. One more thing, I think, what are the some important metrics? We define many different metrics. What are the most, or some of the most important? Number of false tracks, tracker dependent, algorithm free, and cardinality measure, right? Number of false tracks. Track probability of detection, it's still tracker dependent, algorithm free, and also cardinality measure. Fragmentation rate, one of the important thing, track latency, time measures, cardinality, algorithm free. Swap count, it's still algorithm free, cardinality measures, RMS, it is the accuracy measure, right? Accuracy measure. And sometimes the metrics, we can do them normalized or unnormalized. Anyway, that's for all for now, defining, explaining performance measurement metrics for tracking applications. Anyway, bye-bye.